The simplest way to think of it is an epigenetic change would be a change that is not in your genome, but will impact a phenotype. So it's just outside of your genes. It can impact your epigenome in the same way it could impact your genome. So I think in a lot of ways that those two overlap. So for instance, there's been evidence to suggest that prenatal exposures, for instance, like stress or even something like gestational diabetes, a disease state, that can influence both your genotype and your epigenome. And perhaps it's the interface together as a molecular outcome that leads to disease susceptibility later in life. So with gestational diabetes, for instance, there are known changes in, say, the placenta, and these infants generally are born a little bit larger, and they're predisposed to developing obesity later in life. But that's both with your epigenome and your transcriptome. It's huge because when you look at these two fields separately, you have world-renowned experts in toxicology, and you have world-renowned experts in epigenetics, and you also have people from government and regulatory agencies. And while each in their own sector, they're amazing and incredibly intelligent, there is a little bit of a gap between these two. So it's a matter of having the toxicologists gain a better understanding of epigenetics and having the epigeneticists understand a little bit more about toxicology and really bringing these fields together. Because coming into the question of how can epigenetics help with risk assessment paradigms and understanding adverse outcome pathways, you need an understanding of both, because before you jump into these types of experiments, you need to be asking the right questions, and to ask the right questions, you need to understand both fields. It's one of the fastest evolving fields right now. When you look at the number of funded projects, it's skyrocketing, the number of papers, it's skyrocketing, and really it's such a fast-moving field that it's almost difficult to keep up with. But what I'd like to see as far as toxicology goes is just people having a greater understanding of what epigenetics means for this field.